today with the crazy snow. I hope everybody is staying warm inside and safe and not going outside because, uh, that's not ideal. But yeah, so we're going to have a nice session tonight. We're going to have our news. I think we have a couple news articles. We'll have maybe a break before I speak, but if not, then I am speaking. We could not get a guest speaker today, but it should. Sorry, I was just responding to something. But yeah, we have me as a guest speaker, so that should be a lot of fun time talking about Ubisoft getting hacked and the Mongol Bleed hack as well, if you know anything about that. So I am not sure who our first session speaker is, but if you go to the next slide and somebody could speak, that would be wonderful.
Yep. Hello, everyone. I'll be the presenter for today. And kick things off, I'd like to talk about a very interesting vulnerability I read about. So many of us use Bluetooth audio devices in our lives, right? Like if you're going to the gym, or if you're just like listening to music or trying to study. So some of us also have conversations with other people with these devices as well. So what if I told you there was a CVE exploit found with particular Bluetooth devices that can allow attackers to potentially spy and track your whereabouts? That possibility is an unfortunate reality with CVE-2025-36911, otherwise known as Whisper Pair. If you use an Android phone, chances are you've at least heard of Google Fast Pair before. It's a feature that connects Bluetooth devices in close proximity, designed to let the user connect their phone to their Bluetooth device with as little interaction as possible. So this is where things start to take a dark turn. In many devices that support the fast pair feature, the technology itself has not been properly enforced in many products that have been released. FastPair uses something called key-based pairing, which utilizes cryptographic key files to secure a connection between the devices for an enhanced form of security. These manufactured devices are supposed to ignore new pairing requests if it is not in pairing mode, but many manufacturers have not implemented the security check in place. So attackers could be able to connect to these devices by establishing a regular Bluetooth connection to devices with this technology using any device regardless of its operating system. So the scary thing about this is that if attackers can gain full control of your audio device. So let's say like you're at a coffee shop in public, right? And someone established a connection to your audio device. And let's say that you're trying to talk to a friend, right? And you're discussing that you going to play Mario Party tonight at 7 p.m. at your house, right? So, um, remember, the attacker can eavesdrop on your conversations and even without interacting with. So, this victim, they haven't even interacted with this person before, and maybe they're not even aware of their presence. They actually would know your address, and they know that you're playing Mario Party tonight. So, in that kind of scenario, it's very, very risky because devices with Google Fast Pair also have a tracker within them. And if they really wanted to ruin your hearing, they could also play audio at high volumes on your device as well. So, even if you don't use an Android phone and you use a phone with iOS, right, you can still be vulnerable to this issue as this is an issue with the Bluetooth devices themselves. The worst part is that there isn't really a way to disable fast pairing technology as it is baked into the accessories. You might be asking at this point, what is the solution? Well, the definitive answer for now is that you will need to wait for software updates for these Bluetooth devices, relying on the companies who manufactured these audio devices to fix them. So actually, Google awarded the people who researched this vulnerability with $15,000, and they tried to work with manufacturers to release software updates. As I conclude my talk, I'm just gonna share a great resource in the stream questions chat in IS for ISSessions, and you can actually tell if your device is infected or not. And it's called whisperrepair.eu. And I have also shared a scenario-based website as well, so you can look at it in action. And I'll pass it off to the next person.
Awesome. That was amazing. Thank you. I have a Google earbuds pair thing, so I'm probably not going to be able to use mine until this thing gets patched. I'm definitely gonna have to check if I'm stuck. So I think we have Nick next. Yeah, take it away.
All right. Can you guys hear me?
Yeah, we're good.
Yeah, all right. So, hello, I'm Nick. If you guys don't know me, I see some new faces in here. I'm a second year, and I've been doing news segments for the uh first half of last semester. So yeah, today I'm going to be breaking down a multi-stage phishing campaign that targeted users in Russia and ultimately deployed both amnesia, rat, and ransomware. This attack started with spear phishing emails containing zip files. Inside these zip files was a malicious Windows shortcut file or a .link file disguised as a harmless document using a double file extension. Uh, when the victim opened it, they unknowingly trigger a PowerShell command. This PowerShell script downloads additional payloads from legitimate cloud services such as GitHub, which helps the attackers evade detection. It also drops a decoy document to keep the user distracted while the attack continues in the background. Um, one one of the most critical stages is the defense evasion. The attackers actively disable Microsoft Defender by adding exclusions, turning off protections, and even deploying a tool called Defend Not, which tricks Windows into thinking another antivirus is already installed. This effectively blinds your system. Once defenses are down, the attackers establish persistence and surveillance. They deploy a .NET module that takes screenshots every 30 seconds and exfiltrates data using the Telegram bot API, which is another legitimate service that makes detection harder. Um, At 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 this point, the attackers deliver at the Amnesia Rat, which was hosted on Dropbox. This gives them full remote access, allowing for credential theft, browser data extraction, webcam and microphone access, and arbitrary command execution. Finally, the attack escalates into ransomware deployment. Your files are encrypted, key processes are killed, clipboard contents are monitored to hijack cryptocurrency payments, and a WinLocker component restricts user interaction. So yeah, that's basically the how the attack works. And what makes this campaign especially dangerous is that it doesn't rely on any software vulnerabilities. Instead, it once again abuses user trust, native Windows tools, and legitimate cloud platforms, demonstrating how powerful social engineering and combined with defense evasion can be. And yeah, that's all I got.
Awesome. Thank you very much, Nick. That's great. I think we have the code for the next slide, so we'll just do a quick break while I get ready for my part. And yeah, we can use the code here. The stream questions, if you go up, there should be a form that was pre-posted before the stream, and you can use that to with the code to get the credits. So we'll see you guys in like 5 minutes or so.
So this is the old report.
All right, guys, we should be set to go. I will be streaming the slide deck because it is easier for me to control than have Sully press the slide deck. So you're either welcome, if you're in Discord, you're welcome to view my stream, or if you're watching online, it'll be the same for you. Sully will make sure the outputs get swapped. So, for those of you who don't know me, my name is John. I recently graduated the program in December. Well, I'm still waiting for the ceremony, but I recently finished the program, and I'm excited to present my first guest speaker session. So that'll be very fun and interesting. So I'm basically here to talk about, as you heard about in the beginning, a little bit about the MongoDB hack or MongoDB MongoBleed issue with Rainbow Six Siege and Ubisoft. So yeah, before I dive into all of the chaos, I would like you to understand something. So this security or this story is more than just a security bug. It's about how one vulnerability can attract multiple groups of people with completely different agendas, and how some of them will lie through your teeth, how you will see, to take credit for something they didn't do. So like I said before, we're talking about MongoBleed, which was a critical vulnerability in MongoDB that leaked uninitialized memory. So here's the kicker. When the Ubisoft Rainbow Six Siege servers got hacked, everybody blamed MongoBleed. But the problem was, they were half right. MongoBleed was exploited at Ubisoft, but not for the game hack. And it actually took a bunch of hackers to fight other hackers to kind of untangle this whole mess. So this is going to be a wild ride, and I'm excited to present it to you guys. So let's get started. On December 12th, 2025, MongoDB's security team discovered something terrifying, a vulnerability in how MongoDB handles compressed messages. They named it or coined it MongoBleed. Officially, it's called CVE 2025-14847. Here's the thing, though. This vulnerability, like all the vulnerabilities I seem to cover at ISSessions, this one has been in MongoDB since version 3x, which was released in 2013. That's over 10 years ago. So this bug has been sitting in production systems for over 10 years, potentially being exploited the entire time with nobody knowing about it. 5 major versions have had this bug in it. It has been sitting through code review and code review. Everybody's just been checking it off. And it was basically a ticking time bomb that went off on Christmas morning. Imagine that. You're unwrapping presents with your family, and no, you got to go fix your MongoDB database because there's a CV that's like 8.7. Yeah, not very fun. So here's what makes the vulnerability so dangerous. MongoDB doesn't validate the size of incoming compressed messages. An attacker can claim that the message is 50 megabytes, but it's actually a kilobyte. MongoDB just trusts it, allocates the full 50 megabytes, and then returns the entire buffer as if it's all valid data. And then the buffer would contain an uninitialized memory, which is garbage that's left over from previous operations. And it's not just a small number that has been found with these databases, as you can see on the slide. 87,000 plus were found on Census, was over 200,000 found on Shodan. Probably even more than that, but these are just ones that are live on the internet. You get a lot of leaks from that. You get logs, environment variables, API session tokens, system information, basically anything that is stored in memory you can get. And the scariest part is you don't even need authentication. You don't even need to be logged in. You literally just send a request and back and get a response back. That's it. That's it. So now, I'm sure you guys have heard about Heartbleed if you've been around in security or even in tech for a good number of years. MongoBleed is off of the same strain. You can call them cousins if you like. Heartbleed was a vulnerability in OpenSSL discovered in 2014 that leaked TLS session memory. It was catastrophic. It was terrible. It affected millions of servers worldwide. It was everything basically broke. MongoBleed is the same vulnerability pattern, the same root cause, insufficient validation of size parameters leading to memory leaks. Different software, exact same problem. I don't know if you guys have browsed XKCD comics, but there's a Heartbleed comic or that explains this thing perfectly. It basically just says, I'll explain it to you. Hopefully you guys can understand it because I can't really copy paste it because of copyright and stuff. But it basically says, server, are you still there? If so, reply potato. 6 letters gets replied potato. Server, are you still there? If so, reply bird. 4 letters. Bird gets replied. Server, are you still there? If so, reply hat. 500 letters. And then it dumps everything behind the hat. That's exactly what MongoBleed does, except with MongoDB instead of OpenSSL. So it kills me that this was in MongoDB for 10 years. The difference for Heartbleed is that this was like a wake up for the entire industry, that we are still like making these issues in the code. And MongoBleed is a reminder that we still haven't learned about anything, which is scary considering how much AI we have in our code and repos and reviewing all that fun stuff. So let me break it down how this vulnerability works. I'm going to get a little bit technical, but not too much, and I'll explain some too technical terms for you guys. But understanding how this works is the key to understanding why it's so dangerous. So MongoDB uses something called OP compressed messages for its wire protocol, basically how the clients talk to the database. The messages use zlib compression, which is a very standard compression algorithm. And like I said before, you do not need to be authenticated to send compressed messages. You can actually do the authentication transaction over the compressed connection itself. So any unauthenticated hacker can just send this request. So inside the message, there's a field called uncompressed size that tells MongoDB how big the decompressed data should be. The problem is that MongoDB doesn't validate the field. It just trusts it. Like all, buffer vulnerability memory exploits, it's just trusted, no checking. So here's what the attack is. An attacker sends the message, like I said before, hey, this decompressed data is 50 megabytes, but it's actually only 1 kilobyte. Mongo goes, sure, let me allocate 50 megabyte buffer. I just trust you, no problem, bro. zlib decompresses the actual 1 kilobyte size into the start of that buffer. Then Mongo returns the entire 50 megabyte buffer as if it's all valid data. And then they have a BSON parser, which is like binary JSON data. And that reads all of that from uninitialized memory. And then all of that memory contains whatever garbage was left in the previous operations. It could be anything. And then it hits a null byte. And then when the parsing fails, the error response includes everything beyond that leaked memory. It's actually really insane. And this part I found through research, which I thought was quite crazy. It's a really interesting perspective and why they were able to leak so much information from the Ubisoft databases. But the way that the glib C heap works, it allocates memory into quote unquote bins based on size. So if you want to leak memory that contains a password that's 6,000 bytes long, you need to allocate a chunk that's 6,000 bytes. So by changing the size field, you're changing which heap bin you're leaking from. So you can systematically leak from different regions of memory just by changing the size field and grab different information from the database. Excuse me, I'm just going to pause for some water. And so, as you can see in the slide, this is an actual picture from the GitHub that I will link in the last slide. And this is the actual fix for the code. They were literally returning the output dot length, and like instead of returning the buffer size, they were returning the actual. I couldn't. This is funny. It's been in the code for a decade. It was fixed like that. Obviously, there was patches released. That was awesome, but there was an issue in some of the versions where they could not patch it. So if you're in a certain version, I don't remember which one it is. Maybe it's 4 and 5, I think. There's no specific fix for it, and you have to migrate from legacy. Oh, you have to migrate from legacy code. And if anybody has migrated from legacy code, you understand the headaches for that. It's definitely a problem. So I talked before about what gets leaked, but we'll talk a little bit more about what gets leaked even more, I guess. So I mentioned clear text password. I mentioned API keys, all that fun stuff. But you also get, connection UID leaks, client IP addresses, fragments of previous database queries, metadata from other user queries. And you would just think, okay, well, maybe all of these transactions and missing data that I see everywhere, it's not going to be that much. Well, in a real world, high traffic MongoDB instance, this would literally be littered with sensitive information. Every single request would have some type of extra information that you could pull from it, from another query. So you couldn't just get passwords, but you can just get artifacts of all previous transactions. By default, glibc memory does not clear memory by default when it allocates it. So if you just allocate memory and send it over the wire, you're still sending uninitialized data without any sanitization, like any checking, any like confirming of the data. So an attacker could send 100 of these requests, or hundreds or thousands of these requests, each leaking different memory regions, pulling all the data together and then compiling it into one big puzzle and going, look at all this source code. And it's not theoretical, this actually happened, right? So now we get to talk about MongoDB's response, which was actually amazing, and why I think this actually happened so quickly. But on December 12th, MongoDB discovered the issue. By the 14th, which was 2 days after, they had worked continuously to validate and fix it. And then by December 17th, they patched over 100,000 cloud instances, which was insane. And then they allowed people to patch their self-hosted instances as well, and even included instances with maintenance windows as well. And then they published the CVE on the 19th. They had transparency. They were very comprehensive about what happened with it. They didn't hide it. They didn't downplay it. They said, this is what happened. Make sure you update. Here's how you update. Sometimes you can't. You have to merge or you have to upgrade your systems, etc. Cool. Awesome. That's great. But then 4 days after December 23rd, we hit December 27th. And that was when Rainbow Six Siege got hit. So this is where it gets kind of interesting and kind of funny, and why I wanted to talk about this in the first place. But on December 27th, Rainbow Six Siege servers got hacked. And when I mean hacked, I mean every single player in the game received 339 billion R6 credits. And in Ubisoft real money prices, that's about $13 million per player. But hackers were also banning and unbanning players. They were unlocking exclusive cosmetics that cost money. They were unlocking exclusive dev items that, if equipped, would ban you permanently. They were causing servers to go up and down. Ubisoft just said no and caused the servers to go offline for 24 hours. Everybody was confused. They're saying, should I spend it? Should I not spend it? Some people who did spend it got it like revoked. They had to like pay Ubisoft back because that wasn't the money that they had. So they're in like the negative amounts on their accounts, which is pretty insane. But here is where it kind of went insane. Everybody, including the hackers, which is why I think everybody ran with it, immediately blamed MongoBleed. And I'm sure you read them. The headlines wrote themselves. MongoDB vulnerability leads to Ubisoft breach. MongoBleed causes Rainbow Siege 6 hack. When I was reading them, I'm like, oh, wow, yeah, interesting. But you're thinking about it and you're like, yeah, but this doesn't really make any sense. Because well, if you read into the articles, they were talking about how databases were being leaked and how many group and hackers were claiming they had information. But in a critical vulnerability in a database system where a major gaming company gets hacked like this, it's not always the full story, right? So the dots were partially right, but they were mostly wrong. MongoBleed was indeed exploited at Ubisoft, but not for the R6 siege hack. It was used to steal the source code, 30 years of development code, or quote unquote steal the source code. We'll get into that later. But the the R6 siege currency hack, that was not even MongoBleed at all. That was a completely different group, completely different attack. They just used MongoBleed as a cover. Why not? More view to them. This is pretty simple. So how many groups were involved? There were 5 different hacker groups involved. 5 different hacker groups. I don't know if you guys are aware, but there is a group on Twitter, or a person on Twitter, called VX Underground, the threat intelligence group. And they discovered that there were many groups that were having different claims, different capabilities, different levels of honesty, telling whatever they wanted. It was very, very interesting. It's like watching 5 different heist movies at the same time, all at the same topic. It was some of them were telling the truth, some of them were liars. It was very interesting. So the source code was stolen. MongoBleed was exploited. Like we said, the R6 siege hack was a separate incident. But everybody's so confused. Like, they were both hitting Ubisoft at the same time, both initially attributed MongoBleed, only one of them using MongoBleed. It gets better. All the groups, they know each other. They're literally part of the same gaming community. They're part of like a hardcore group of Ubisoft nerds who all have different reasons for attacking the company because they hate them or whatever reason. So let's walk through the groups here, because this is where it starts getting pretty interesting. So Group 1 is the only group that actually did something verifiable. They're the ones who exploited Rainbow Six Siege. But like I said before, they did not use MongoBleed. They just exploited game service APIs. Think about this. They just exploited insecure APIs. They had access to the game inventory system and the moderation system. They were able to grant themselves access to all of those systems and give players billions of credits, unlock cosmetics, just for fun. Why not? Let's have fun. Ha 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 ha. So, yeah, this was the only group that caused real damage. This is the group that made the headlines. I'm not sure if this is the group that claimed the MongoBleed. Maybe it was a different group, but that was what made the headlines, and that was why it went so big. Excuse me, I'm just going to pause for water again. Right, so now we're on to groups 2 and 3. This is where I think it gets funny. Group 2 claimed they exploited MongoBleed to steal 30 years of Ubisoft source code. Everything from 1990s to today. All the development tools, all the internal systems, everything. Here's the thing. They do have the source code. They did not lie about that part. MongoBleed was used to get it, but here's where they lied. That was not their primary attack vector. They had another primary attack vector that was not mentioned in any of documentation that I found, but they used MongoBleed to put the puzzle pieces together, all the missing memory segments. Group 5 claimed that Group 2 had lied about, had lied about having Ubisoft access through other systems, probably just through old previous phishing credentials or some old breach that they had never mentioned. And they just used MongoBleed as a cover story. And then they saw Group 1 making headlines, and they said, we're like, yeah, let's just use it as a headline cover as well. Group 3 is even worse. They claim to compromise Ubisoft customers' database and then exfiltrate that data via MongoBleed. They started sending exploitation messages to Ubisoft users on Telegram, threatening to leak customer data unless Ubisoft would pay up. But here's the thing, all of that data was fake. None of it was real. They were just making it up to join in on the fun. Why not? Okay, cool. Nice. Now we're on to Group 4. Group 4 didn't really have too much information to find, but they're really important because they were very critical of Group 2, and they were basically the ones to find out that Group 2 was not doing anything properly. They were basically saying that Group 2 was trying to bamboozle 1. They were trying to bamboozle, the entire user base. basically Group 4 was calling out all the BS. They're not attacking Ubisoft. They're not leaking data. They're just trying to judge like what's kind of happened, what's true, what's false, what's going on. Wait, what doesn't add up, kind of thing. So they just have a little small part to play, not too much. Then we got Group 5. This is where everything came to a complete close. Group 5 is actually a skilled group of hackers. They're different than these for fun gamer groups that maybe have some access to some, vulnerabilities from the dark web, whatever. These guys are skilled reverse engineers. They know the code inside and out. They literally showed up on the scene because they were annoyed that so many groups were straight up lying about Mongo Bleed. So they provided a step-by-step technical breakdown of exactly how Group 1 performed all their actions. They provided photographic evidence of how Group 2 actually got access. Then they had code demonstrating Group 1's methods and capabilities. And then obviously Group 3 didn't do anything, so it wasn't matter. Group 4 obviously wasn't involved as well. So it was funny. Group 5 was like, okay, calm down, guys. You didn't actually do what you said you did. You're not actually huge hacker groups. You're just using this as a cover. I thought that was pretty interesting. And even VX Underground joked about it at the end of the tweet. They were like, this anime saga has concluded, because it was like a whole drama series. Everybody was just laughing around with it. Nobody was taking them seriously. It was pretty funny, to me at least. So thanks for sticking with me this whole time. We'll go over some lessons and takeaways, just a little interesting final few slides here. But what do we take away from this? Right. So Mongo Bleed is real and critical. Over 87,000 exposed instances need patching. This is a serious vulnerability that requires immediate action. Second, history repeats. Heartbleed in 2014, Mongo Bleed in 2025, same root cause, trusting user supplied parameters. Different software, same lesson, we didn't learn it. What the heck? Third, not all breaches are what they claim. Multiple groups will fabricate and misrepresent themselves about their involvement. They saw an opportunity, jumped, and lied about it. When you see headlines about a breach, verify the claims. Don't just trust willy-nilly when you read the article. Fourth, Mongo Bleed was actually exploited. The source code was stolen. Well, put together through other exploits. But it wasn't the cause of the R6 siege hack. Two separate attacks, both hitting Ubisoft, both attributed to Mongo Bleed, but only one using it. This is why, like I said before, you got to verify and find evidence that actually points to, that article being correct or incorrect. Fifth, chaos attracts opportunities. 5 groups, 5 agendas, 1 disaster. When something big happens, everybody wants a piece of it. Some of the groups will make up stories to get attention, as we've seen with this, and other groups as well. Transparency matters. Both MongoDB and Group 5 proved that technical expertise will beat all this, dumb stuff. They provided evidence, they provided code, they provided analysis, they provided troubleshooting, maintenance, how to fix, all these credible information sources. And finally, the real damage from the R6 siege hack was simple. Group 1 did not need Mongo Bleed. They didn't need sophisticated. They just needed basic game APIs. And sometimes the simplest exploits are the most effective, like not checking a length for a buffer overflow or fun stuff like that. But yeah, here's the real lesson. Bug it's been in the wild for a decade, sitting in production systems the entire time. This thing went through thousands of code reviews, thousands of PRs, thousands of people going, yeah, okay, check. Yeah, this is good. This is good. So even the simplest bugs can have the biggest impact. I think now, especially with AI coming about, you have AI writing PRs that have 10,000 lines of code that are being changed. It's like, okay, this is insane. Like, this is not cool or fun. This is scary. Like, we have to read through this code to make sure that this is not going to break a production system. That's a lot of work, So anyways, always patch vulnerabilities, verify with evidence, slow down on coding fast. Anyways, this is my slide deck. I hope you guys enjoyed. I got my sources here as well. Akami's blog was great. MongoDB had a great blog. Obviously love the Primogen low level as well. And then their official repository for MongoDB's exploit. And then obviously VX Underground on Twitter. But yeah, that's it for me. I really hope everybody enjoyed. Thanks again for your attention. If you guys have any questions now or after, I'm open for that. But yeah, thank you guys for listening. Okay, well, that was it. Obviously, I'm also the MC, so thanks for attending, everybody. We really appreciate it. I think we were supposed to do a special announcement for something, but everybody is very sick, so I'm not sure who will be able to do a voice message for that. Maybe, I don't know, Jamal wants to write something about an announcement he'll make soon with Nate. But yeah, we really appreciate everybody attending. Hopefully in the next 2 weeks, we'll have another guest speaker that's not me to come and present for you guys. And yeah, hopefully we'll have that session in person as well. And I'll be there to meet you guys as well, say hi. But I hope everybody enjoyed. That would be it, I believe. I don't think we have anything else. So, oh, Nate's here. Perfect. I don't know if Nate wants to say something.
I didn't get to be here at the start because I got stuck in traffic. I was driving home. Yeah,
No
so I'm not sure what exactly was discussed at the start. So I'm happy to just super quick just mention a couple things. We are going to be officially launching details of the CTF this week. I know that's kind of like a big thing. It's going to be, just for the people here, it is going to be like a fantasy theme. We're going to be posting a lot more details as to what that means, how we're going to be incorporating that. It's going to be it's a similar format somewhat to last year. We're also have the pleasure of having it at KPMG again this year. So I'll be posting an announcement probably tomorrow with all the dates and additional information about registering and everything. My main thing is just make sure everyone who wants to participate has like a CTFD. Start kind of going about, making your teams if you guys want to participate in groups. It's, again, teams of up to 4 people per team. And again, we'll have more details on how to register your team, tickets, all that kind of stuff. It is going to be happening in February again. That being said, it's going to be towards the end of February. It's going to be the weekend of the 21st and 22nd. Again, I'm going to post an announcement. So you guys don't have to remember this off the top. I'm going to be posting all the important things next or tomorrow. But that's kind of what we've landed on. We're really excited because it's going to be very similar to last year in the sense that we have a lot of sponsors, a lot of intricate ways that we can introduce challenges. We thought the Spotlight Challenge idea was well received last year, so we're going to have something similar to that, but a little more in line with the theme and everything. So I think this year we've kind of, I want to say honestly, we have a much cooler theme. So if you really liked last year's theme and how we executed that, I think this year is just going to be so much better. We have more time to think of ways we can kind of change it a little bit and make sure everything looks good. So again, more information coming tomorrow. We'll have, obviously, I think it plays out that there's like 2 sessions between now and the CTF. So we're also going to be going a lot more in detail at those sessions. We're going to be dedicating more time to our CTF and preparation for our CTF in those coming weeks, like more of middle segments being leaned towards likely CTF intro, some previous challenges that we can kind of make sure Sheridan stands out. We host it for everyone in Canada to come out, but we obviously prefer you guys to do well. So we're going to be doing kind of some training. We're going to be going over some previous challenges, more details about the theme. We're not going to give you hints, and we can't really tell you about the challenge or show you anything that we have for this year. We want to keep it fair, but we're going to be at least going in more detail about the CTF and theme and all that stuff in the coming session. So I'm looking forward to it. I think it's going to be awesome. And I think you guys are going to be able to see Jamal in a full wizard outfit at a downtown Toronto office building. So I think that's going to be
also
fun.
Be there.
Yeah, so we're going to be wizards. That's going to be quite fun. I'm looking forward to it. And I'm very, very excited. So again, more information coming. Yeah, that's all I had. I think that's it for the session this week, right? I think John, you kind of capped it
that's
off there.
completely it. That's it. So everybody, please, stay safe, stay warm. If you're outside, get home safe, and we'll see you guys in a couple weeks.
Yeah, exactly. Okay, bye everyone. Thank you so much.
See you guys. John. No worries.